Okay, so what we're going to do is set up a Nutanix cluster on Amazon AWS and then install X-Ray and run a quick test to see what kind of I/O performance we can get from a Nutanix cluster running on Amazon. So logging into mynutanix.com and I've selected the little chiclet thing there that tells me all about Nutanix clusters. I'm doing a free account, so I just click on Create Cluster. And I'm going to give this a name so that we know what we're referring to when we go inside the AWS panel. I'm going to create a new VPC just to keep things segmented, and this seems a reasonable IP range to use, so we'll go with that. We'll click on test connectivity. I'm not entirely sure what that does, but any kind of testing we can do as we set these things up, I think that's a good idea. We're going to allow Prism access from the outside so that we can actually get to it. We'll add the IP address, that's just of my browser, so that I can get to Prism just from my laptop. Now if you're using a VPC in Amazon and you're connecting your own data center to it via some kind of direct connect, then maybe you don't need to do that, but I'm just at home with my laptop and I'm creating this cluster in AWS, and so I need to be able to access Prism from my desktop. So I'm going to create this key in case I need to SSH or do anything like that, download a copy of that in case I need it later, and click through there. So let's just take a quick look. The Z1D metal, that's just the default I get if I'm making an account, making a cluster with a free account. If you're running kind of full fat, you can choose a variety of different instance types. So I've clicked the Create Cluster button, filling all the bits and pieces, and basically what's happening now is we're actually going out and provisioning a bare metal cluster in AWS, and then we're going to instantiate a Nutanix cluster on top of 3 bare metal nodes. So this takes a little while, and we'll just kind of wait for this to complete, and then we'll be able to launch the cluster, or I should say the cluster will be up and running. We'll be able to launch a Prism connection to it and actually get in and see my Nutanix cluster running on AWS. So sped this up a little bit, and we'll just wait for the cluster to complete creation. I think this takes somewhere maybe 20 minutes, 20-30 minutes to get this up and running if we were doing it real time. So not too bad, certainly a lot quicker than having to go to a lab and wire things up by hand. So, okay, by the magic of speeding things up, cluster's created. It's called Gary X-Ray Demo, and we'll use that when we go particularly into the AWS side, just so that we know which of our clusters we've got. Because I've been doing a couple of things in AWS, so I have a few bits and bobs lying around. So there we go. Take note of that VPC ID down there. It's VPC 0D35. We'll need that when we go into AWS console. So meanwhile, we'll launch up a connection to Prism, and yeah, this looks exactly as it would do if I had physical blocks in my own data center or my own lab. So connecting into as admin for the first time, it will make me choose a new password. So we do all that. The beauty of this really is that everything looks exactly the same as if these were physical boxes in my own lab. It's very nicely integrated. Done a pretty good job with that, I think. All right, so as I say, first time logging to Prism, so type in a few details here. And then we'll be ready to do some stuff. Click OK. All right, here we go. So yeah, just the Prism UI that we know and love. So the first thing I'm going to do now, or the next thing I'm going to do rather, is I'm going to go and download X-Ray image. So nutanix.com/X-Ray will redirect me to this page. And what I'm going to do is I'm just going to copy the URL for the AHV image of X-ray, and then what I'm going to do is I'm going to create an image on my Nutanix cluster just like I would normally. Rather than downloading it, I'm just going to pass it the URL and have Prism download in the background for me. So there we go, copy it to my clipboard. Now I'm going to jump over to the image service, create a new image, give it that URL that I just copied from the X-ray download page, and this Prism instance will start downloading that for me so that I can start creating VMs from the image. So save, and yeah, I'll start downloading it. There we go. Yeah, so it's the image create step, and part of that is simply just downloading the image over the internet. So it'll take a little while. Whilst we do that, whilst we wait for that image to download, we can actually jump over to the Amazon side and start getting ready a few things that we know we're going to need in order to make this thing work. So in particular, we need to create a new subnet. I'm going to create a load balancer so that I can access my X-ray VM once it's up and running. And as part of that, I need to make some edits to the security so that the load balancer can talk to this VM, this X-ray VM. So yeah, so what we need to do is we need to create another subnet for X-ray and the worker VMs that it's going to create so they can talk to each other. So my VPC, I have to make sure I create that correct one. So remember when we create the cluster, we noted down as VPC 0D35 and a bunch of things. So make sure we keep that. And I've created a new subnet at 10.0.10.0/24. And this is the subnet that X-ray is going to talk to. Now, by default, it associates it with a routing table that only has access to a NAT. And since I'm coming in from the outside, I need this IGW, which is Internet Gateway. So I've kind of made sure that my subnet is associated with the right kind of routing table. And that means that I can come in and access my X-ray VM from the outside, just like I was able to access my Prism. So there's a 10.0.10.0/24. So I've created that network now on the Amazon side and the AWS. AWS in my VPC now has that network created, but I need to tell AHV that I've done that, and so that it can use it. So the way I do this, I go into settings, network configuration, and I basically just tell it, hey, I've created on the outside a network called 10.0.10.0/24, and I want AHV to be able to access it. So I've done that, and what we'll also have is make sure that AHV is going to act as our kind of IPAM and dole out some IP addresses for us. We're going to do the range from 64 to 128. We don't need too many, so that's nice and easy. So now I've created the network on the AWS side, and I've associated that with a network on the Prism AHV side, so that those two things are now able to talk to each other. So my X-ray image is downloaded from the internet. Now I'm going to create the X-ray instance, so the actual VM itself. I'm going to give it 4 vCPUs, 8 gig of memory, doesn't need too much. And at this point, so now I add the disk. It's the only image file I have, the only image I've downloaded, so the X-ray image just pops up there by default. Add that. So I've got my disk, and now I'm going to add the NIC. And the NIC is going to be connected to that X-ray network I just created in Prism, which is connected now, because it's the same IP range, to the subnet which I created in Amazon. So that's all linked together now. Alright, so I've got my X-ray instance, and I just need to power it up. So click on X-ray instance, and then scroll down and click the power on, and we should start to see that thing come to life. What I'm going to do when this comes up is I'm going to take note of the IP address of this X-ray instance, and I need that so that when I set up my load balancer in Amazon, which I will use to forward traffic from the internet, i.e. my laptop, into this X-ray instance, I'm going to need to know the IP address that the X-ray instance is running on so that the load balancer can forward to it. Now normally if I was just running X-ray as a standard AWS instance, I could point my load balancer at the instance itself, but because we're on bare metal, the instance as far as Amazon is concerned is the bare metal server. It doesn't really know anything about the VMs or the IPs inside of that. So I'll show you what you have to do. So you go to load balancers and create a new load balancer. And we're going to select the TCP TLS UDP, which is a little bit more flexible. So we'll select that, give it just any name, doesn't matter. I'm going to call it X-ray demo load balancer just to keep track of it. And I'm going to point this at 443 because I don't want to go straight through to the X-ray HTTPS port. So this is just a demo, so we don't have to do anything too fancy. Again, make sure I connect the right VPC, and the subnet is going to be my X-ray subnet, right? Because I want to go and talk to my X-ray VM on the user VM network what I created earlier and I configured in Prism. So, yep, this all looks good. I don't really understand all this TLS stuff, so we'll just go through that. I'm going to create a new target group, and it's a target group. So normally a load balancer is going to look at a whole bunch of things running, but in this case it's just my simple X-ray VM. And again, I'm going through the port 443. I'll call it X-ray demo TG for X-ray demo target group. And now I'm going to register the target. So it knows the VPC, and now I'd simply put in the IP address of the X-ray server that I want this to forward to. So 10.0.10.74. Just double check, yep, that's the IP address of my X-ray VM running. So that's what I want to forward it to, add it to this list, and move to the next step. Okay, so this all looks good. Let's create that load balancer, connected to the target group. Target group knows about the IP address of my X-ray server, and we just need to let that all connect together in AWS. It'll take a little bit of time. But now we've got a way of talking to our X-ray VM from the outside world. Now, I've been creating a bunch of things here. The one that we're doing right now is X-ray demo TG, this one. Yeah, okay. Again, because this is a load balancer, it wants to monitor the what would normally be the set of VMs or the set of services that it's balancing between. So it takes a little while to get this set up, but what we're going to find is it's going to come back and it will be unhealthy, and that's one thing we need to fix. So let's just click on this. It takes a little while to register. So here it is, registering, and we'll probably do a bit of a speed up here whilst this thing gets initialized, because there's not very much to see until it gets done. What we're looking for is that word initial in the status at the bottom there, and it's going to come up with, I think, error once it comes up, unhealthy, that's right. And the reason is because the load balancer can't talk to the X-ray VM, even though it has the right IP addresses, because there's a security group for all of the UVMs that we set up by default when we create the cluster. And that security group doesn't allow the load balancer to talk to the VM. So I'm just going to override the security group, and I'm going to do it in quite a blunt manner. So there's probably better ways of doing this, but for now, just for the purposes of this demo, in my security group, I'm just going to let access from the outside world anywhere just to come and talk to this X-ray VM. It has to go through the load balancer anyway, so I don't think there's too much of a security issue, but it's just my demo X-ray VM, so I'm not too worried about that. So I need to make sure I find, so right now I'm just looking for the security group. It's there it is. And again, I've got a bunch of these things on here, so I need to make sure I'm looking at the right VPC. So the VPC is 0D35. So let's just go find, make sure we've got the right one there, 0D35, and it's the UVM security groups. Yeah, this is the one I want. Let me click on that. And then I'm going to add an inbound rule to allow connections from the load balancer to come into my only UVM, which in my case is an X-ray VM. So I have all traffic there, but it's restricted. So I'm going to override that and add like an unrestricted access to this thing just for the purposes of this demo. So yeah, all traffic, and I want it to come from anywhere. Yeah, that will do. So yeah, cool, let's save those rules. And when I go back to the target group, it will take a little while to figure out because it needs to reprobe the VM and identify it as healthy. So it'll take a little while to do that. So we'll probably just pop off into Prism and do some other work whilst we wait for this to resolve itself. Let's just make sure. Here's our load balancers. X-ray demo load balancer is my one. It's the listener that I'm trying to fix. Looking forward into this target group, and currently it can't reach the target group because of because of the security. Even though I fixed it, it'll take a little while for it to reach out and acknowledge that it can now get good access to the X-ray server on the back end, and that will change to healthy or something. So whilst we wait for that, let's go off into X-ray. What we're going to need actually is a virtual IP address. So the easiest way to do this, because this is a very small thing, I'm just going to go choose an address that's in the range, in the 10.0.128 range, because that's what my UVMs are on. And I'm just going to choose an unused address because I'm not going to be adding any more IPs onto this thing, so I can just choose one. As long as it's not being used by a CVM, I can just choose whatever I like. So I'll probably choose 10.0.128.101 or something like that. That's not being used and it's easy to remember. So cluster details, virtual IP. I need a virtual IP because X-ray needs to talk to the virtual IP. It won't work if I just point it at a CVM. So I'll save that. And then we'll just do its thing. So when I can finally get access to my X-ray server, this virtual IP 10.0.128.101, that's the IP I'm going to point to when I set up a new target. Okay, great. So now time has passed. The monitor, the health status has been able to reach out and hit that X-ray IP on the back end, so it's now healthy. So my load balancer should now work. So what I do is I select my load balancer and I basically should be able to access my X-ray VM by this DNS name / URL. So because I'm going to port 443, is that 443 on the end and put HTTPS on the beginning, and hopefully we'll be able to access our X-ray server. Okay, this is a good sign. We know the certificate for X-ray server is self-signed, so I expect to get this. Let's just do what we need to do to accept our self-signing risk. So yeah, all good. Oh, brilliant. So here we are. Now we're talking to the X-ray server at the back end. I'm coming from my laptop. I have to set a password for the local store because I'm going to store cluster credentials like usernames and passwords. So I want to make sure that's secure. Yeah, blah blah blah. I'll read all this. Yeah, sure. Bang, accept. Yeah, fine, whatever. Right. So now we're in X-ray, and we have all of our normal tests. I'm not going to set up an IPMI, so I'm just going to do a simple four-corner performance test. So first thing I have to do is set up the target. If you're familiar with X-ray, this is what you need to do. So this is the cluster I'm going to be testing. It's actually the same cluster which this X-ray server runs on, which is fine. I'm not doing any failure testing, so this will be completely fine. Now this is my 10.0.128.101 IP that I created, so the virtual IP I created just a second ago, and I'm logging in. This is my Prism admin username and password. Okay, so X-ray's gone out and probed that, come back and found the containers and everything, so this all looks good. So now I know X-ray server can talk to the virtual IP, and yeah, so far so good. I'm going to run the validation, make sure I can actually spin up some VMs on the back end. Not much is going to happen if I can't do that, so this validation step will let me know if that's all working. So let's see. We should see here as the validation step executes, we should see a couple of Curie VMs, which is what X-ray uses. It uses that naming scheme. Curie is the back end of X-ray. Anyway, so it's created these VMs, just some test VMs. So now we can clone. We know we can clone It looks like these are spinning up, looks like they're getting IPs, but they're getting the IPs from AHV, from that network we created. We said, please dish out some IP addresses. So yeah, this looks really promising. So we're just right now just running this validation stage. So it has to clone them, power them up, make sure I can talk to them. And if we flip back over to X-ray tab, we should see that it's pretty close to finishing. I've sped this up a little bit, so if you're doing this for real, it may take a little while to spin up these VMs. Not too long. It's definitely worth doing. Okay, so this is completed. Fantastic. So there we have. There's our target. Now we can go run a performance test, which is what we came here to do. So yeah, we'll just select this one. Easy peasy. We know what it should look like. Point it at the cluster that with the target we just set up, and let's let it rip. Let's see what happens. So X-ray is just making sure there are no old VMs lying around that it created. We'll start cloning them out, powering them up, pre-fill the disks is one of the things it does, just to make sure testing is sane. Otherwise, like a lot of modern storage, if you don't write the data out and you read from an empty space, there's massive optimizations there and you get giant performance numbers that aren't indicative of what you'll really get. So we pre-fill the data, we pre-fill the disks with random data just so that we're not getting a misleading number. So here we go, here are those Curie VMs. This is what X-ray uses to do the work. So I've got 3 of these because I've got 3 nodes in my cluster. So in this particular case, I can drive a lot of I/O just from these 1 VM per host, just because we're not doing any processing, so there's not a lot of CPU use. It's just doing reads and writes. So this is starting up, booting up these VMs, and then X-ray will do the pre-fill, do the warm-up. So it's already done the pre-fill, and now it's warming up the caches so that we get a steady state number. We flick back into Prism, we'll probably see some IOPS being generated. We'll be able to see that in the UI here. Yeah, okay, so you can see the control. It's doing a random read test, so you can see the controller IOPS. Yeah, these aren't really real time, so it takes a little while for the metrics to pop up in Prism here. But yeah, these look like pretty sane numbers. Looking at these on a per VM basis, we look at the thing overall. Yeah, so I'm doing 100,000 IOPS, so I expect that to get quite a bit larger, but there's a little bit of lag on this UI because it's not continually polling real time. That would be quite invasive. So this will increase as it continues to sample. Like, yeah, it's already up to 166,000. So I'm expecting probably in the region of about 700,000 IOPS. This is only a 3-node cluster, so there aren't many nodes here, so it's not going to be a massive number, but it should be decent. That's UM. Yeah, so still warming up. Latency is pretty good, millisecond, considering we have a decent queue depth here. Yeah, we'll just wait for this to warm up, and then as soon as X-ray moves into the main piece of work, it will start generating output. If you saw there, flicked by quickly, but I think we was already up to 600,000 IOPS on these 3 nodes, so yeah, doing pretty well. Wait for this warm-up to finish, and then we'll start getting some pretty charts. What I'm going to do is I'm going to speed up the results here because I've got numerous other videos that show how to run X-ray. So the main purpose of this video was to show how to set up X-ray on AWS and connect it all together. Once you've got that, you can just go and use X-ray just like you would on a regular data center. But we'll just see this go through, make sure at least we're going to get some charts out of this. Okay, so the warm-up is finished. Okay, so now we're running the random read. going to ramp up a little bit, see where we get to. There we go, so we're already at, wow, yeah, we're already at 700,000 or so. Unfortunately, these median and means get washed out a little bit because it includes this ramp up. So these aren't terribly useful, but you can see here now the steady state doing about 700,000 IOPS out of 3 nodes, 3-node cluster in Amazon. So yeah, pretty solid figures. So next we'll do the sequential read. Interesting to see what kind of throughput we get from these devices running in AWS. I believe they're NVMe drives. You can't see the physical devices because you're going via the Nitro card inside the AWS hosts themselves, the bare metal. So Amazon will tell you something if you do add a SCSI or an NVMe list. But you're not really seeing the real devices there. You're seeing whatever it chooses to show you. So these are pretty good numbers. Remember, this is only a 3-node cluster, and I'm getting 16 gigaseconds, and it's over 5 gigabytes per second per node. That's pretty good. So there's definitely real NVMe drives at the other end of that connection, because there's no way you'd be going that fast unless you had a lot of SSD. So that's pretty good. So the next test will be random writes. We'll see what we get for those. Won't get anywhere near the 700,000 there because we have to replicate across the wire. I'm not sure what the connectivity at the back end is here, but still, 300,000, not too bad. 100,000 per node, pretty good. Unlikely you would need more than that in the real world. The last one should be sequential writes. Let's see what the bandwidth looks like. Yes, you see some charts here in Prism. Not hugely useful just because in a short test like this, they're averaged down. Gives you an idea of what's been happening. Here's a sequential write throughput. Yeah, again, 2.5, 2 gigasecond there. We only have 3 nodes, so not too bad. I would expect that to be close to 3 gigabytes per second. I'm not exactly sure what's happening there. I do know that when we configure these, we have each node is in a separate rack to improve resilience. So maybe that has something to do with it, I'm not sure. But anyway, 2.5 gigasecond, not too bad for three nodes. Yeah, really seeing the benefit of the data locality there on the read side, getting 16 gigasecond. Most real workloads are very read intensive, so that's good. So there we go. We've set up a Nutanix cluster in AWS. We set up an X-ray server to run on that cluster. We did all the plumbing to get that to work, and ran an X-ray test. So there we go. Not too difficult. Thanks a lot. Bye bye.